Hi, my name is Mackenzie Smith, and this is my video for the first lab. I've included the following equations to highlight the chemical processes happening during each step of the procedure. First, the aluminum dissolves in concentrated potassium hydroxide. This transforms the aluminum solid into an aqueous compound combined with several hydroxide ions. Once the aluminum completely dissolves, the highly concentrated sulfuric acid is added, and the previously aqueous aluminum hydroxide compound has a single hydroxide ion removed from it, and this results in the fallout of a precipitate. After the remaining sulfuric acid is added and the solution is heated and constantly stirred, the aluminum hydroxide precipitate slowly dissolves back into the solution. This stage is essential because now the aluminum is available as an aqueous ion. Finally, the aluminum ion combines with water and the potassium and sulfate ions to produce alum. The alum product separates from any impurities when the solution is placed in an ice bath. The alum precipitates while the impurities stay dissolved. This is due to the differences in solubility between alum and the impurities. Alum is insoluble at lower temperatures compared to the other impurities in the solution. This picture shows my concentrated solution in a glass vial after approximately 4 days, and there are still no crystals present. In order to produce NaCl crystals, you first need to make a highly concentrated solution of NaCl in water. Heat the water to a temperature close but not exceeding boiling point. This increases the solubility of NaCl in water and will eventually produce a larger quantity of crystals. Slowly add the NaCl while stirring until it no longer dissolves. Filter out any remaining undissolved NaCl and place solution in a glass vial and cover opening with a chem wipe to allow the solution to slowly evaporate. Eventually the crystals will begin to appear as the solvent evaporates. Another method for growing crystals is liquid-liquid diffusion. In order to produce high-quality crystals, this method requires two different solutions with varying densities. The higher density solution is placed below the lighter one, and over time the solutions are allowed to mix. Once the solutions combine, a crystal precipitate can form. A drawback to this method is that there are few solution combinations that can successfully produce crystals through liquid-liquid diffusion. Here are my citations.